Natural gas is highly versatile and used for an enormous variety of applications. As a fossil fuel, it serves principally for heating residential and commercial premises, as industrial process heat, for generating electricity, and as fuel for motor vehicles. Gas is indispensable in our modern-day world, and indeed it is taken very much for granted. This is why our supply of gas has to be secured. International connections and long-term agreements make sure that the gas actually reaches us. Our task is to make sure that it arrives safely. TÜV Hessen, with all its expertise and experience gained from almost 20 years of pipeline construction testing, is, for this line too, also responsible for ultimate comprehensive testing. In this case, the gas comes from Siberia. Our subject is the Baltic Sea Connecting Pipeline, Opal for short. It begins in Lubmin on the German Baltic Sea coast and runs for 470 kilometers to the Czech Republic. The client is WinGas, a joint venture owned by the BASF subsidiary Wintershall and by Gazprom, headquartered in Kassel, Germany. Opal boasts some very impressive figures, more than 26,000 pipe sections, each of them 18 meters long, 1 meter 40 in diameter, and weighing 15 tons, and each individually formed to meet the topographical challenges. A project of massive dimensions involving numerous challenges that had to be met and mastered. Along its route, Opal crosses 172 roads, 3 major rivers, 39 bodies of water, and 27 railway tracks. The gas pipeline provides an annual transport capacity of 36 billion cubic meters of natural gas. This corresponds to the annual amount of energy produced by 15 new nuclear power plants. Highly complex projects demand highly professional specialists. The expert appraisers from TÜV Hessen are acknowledged specialists in their chosen field. Besides a university degree, they also hold qualifications as specialist engineers for welding and non-destructive testing. Our work begins by verifying fundamental eligibility for approval and obtaining an expert appraiser statement. The next step is putting theory into practice, and this requires professionalism and precision. These specialists on this site are the welders, carefully chosen professionals from Italy, Spain, Germany, Poland, England, Turkey, Romania, and Austria. Their task to weld 26,000 seams under on-site conditions. TÜV Hessen makes sure that only properly qualified craftspersons are deployed, as evidenced by proficiency tests and the validity of their welder's examination in accordance with EN 287-1. For Opal, 3 types of welding are used. The preliminary constructions are welded together using a metal active gas process. Then they are connected by hand using electric welding. And at the stations, the weld seams are created by hand using a TIG process. During all these operations, we use random sampling to check the temperature control during welding, the pre-warming temperature, the intermediate layer temperatures, and the cool-down speed. Then, every completed seam is subjected to a visual inspection. The subsequent lowering of a pipeline section under the stern gaze of our expert demands precision down to the very last millimeter. The ultra-professional side boom crane operators do their job with an exceptional delicacy of touch. The finished weld seams are meticulously tested in both destructive and non-destructive procedures. The non-destructive tests are conducted in 3 different procedures. These tests are part of the construction company's remit. All the seams created in the preliminary work are checked using a mechanically guided ultrasonic scanner. Approximately 30% of these preliminary construction seams are additionally irradiated by an X-ray tube. The results of these tests are meticulously examined by our expert appraiser, seen here studying the X-ray film. When examining the guaranteed seams, an additional ultrasonic test with a handheld sound source makes double certain. In the case of sockets or fillet welds, the magnetic powder crack test procedure is used. All results are analyzed on a daily basis, monitored by TÜV Essen to enable the appropriate action to be initiated immediately if it proves necessary. In the destructive test, for each construction batch, 3 defined samples are taken and subjected to an intensive examination immediately after arrival in the TÜV's own accredited test laboratory. All these tests focus on the key mechanical technological figures for the weld seams. The tensile test shows the forces at which elastic deformation ends and plastic deformation begins, until finally the base material tears. The weld seam holds. The macro section constitutes the preparation for examining the sample under a microscope. The enlargement on the monitor clearly shows the base material, the filler, and between each of these, the heat influence zone. The bending test shows the extent of plastic deformation and the quality of the weld seam. The notched bar impact bending test examines the toughness characteristics involved. Test condition: material temperature precisely minus 20 degrees Celsius. The notched bar impact hammer strikes the unilaterally notched workpiece at high speed. The energy that is absorbed while the sample is being shattered enables conclusions to be drawn about its toughness. Finally, the laboratory manager summarizes the result in a test report. If one of the samples is not up to standard, repair work is immediately specified and initiated, after which the sample is tested again. After the details, the pipeline in a hole is subjected to its own test, a stress test in accordance with VD TÜV 1060. For such a pressure test, around 10,000 cubic meters of water are pumped into a section about 6,000 meters in length. The pipeline's operating pressure is 100 bar. For the stress test at 175 bar, another 120 cubic meters of water are added using high-pressure pumps designed specifically for this site. To provide a vivid comparison, the volume of water required, 10,000 cubic meters, would be enough to fill 4 Olympic-sized swimming pools. The test pressure of 175 bar corresponds to the water pressure encountered by deep-sea divers at a depth of 1,750 meters. In the stress test, it is primarily the welding and laying stresses that are downsized. Our expert appraiser continuously records all the measurements taken. As a genuine strength and endurance test, the procedure stresses all Opal's pipes up to almost the actual yield point. The stress test is at present the only test procedure that itself rejects hazardous defects. In contrast to most other test procedures, the stress test serves both to check and also to optimize a pipeline. This enhances the operational dependability and cost efficiency of the pipelines tested. Thus, the stress test has 2 functions. It serves to verify the mechanical strength and at the same time is the final piece of construction work on the pipeline. At the very end, after all the construction work has been completed, a visual inspection is performed from the inside using a Go Devil test. The entire pipe geometry inside is measured by a pig caliber Go Devil. All the facts, figures, and test results are recorded in the pipe logbook, the most important document for a pipeline. Each pipe has its own pipe number. All important pipe data are hard stamped on the outside and soft stamped on the inside, with pipe number, batch number, pipe length, material, and the order number. These data are recorded by the pipe logbook keeper and checked for correctness by the expert appraiser. Plus, of course, the data on the creation of the weld seams. Seam number, date of welding, particulars of the welding team, particulars of non-destructive testing, plus any special features involved. Once the individual sections have been successfully pressure tested and these sections linked up, the job is done. During the startup procedure, the expert appraiser from TÜV Hessen issues an advanced certificate in accordance with Section 6.1 of the German High-Pressure Gas Pipeline Ordinance. A long route involving massive amounts of people, machines, and materials. A gigantic project. For the construction work, 2,500 skilled workers. For ensuring safety, 1 project manager and 7 expert appraisers from TÜV Hessen, supplemented by particularly well-qualified experts for a total of 95 pressure tests. We take our responsibility seriously. With our specialized capabilities and daily on-site involvement, we guarantee compliance with all the relevant technical standards. We stand for the safety and dependability of all the work performed, and thus also ensure that consumers can rely implicitly upon the gas reaching them.